Let's take a look at the question to find area of the shaded region using integration. Now, I'm going to show you two methods, but before I start, let's just find the points of ABC. Since we can see that AB is on the y-axis, so we're going to do x equals to 0. So what we get here is that insert 0 at x position, y squared will be equals to 4. And for y value, I'll have plus minus 2. And since A is above, so A coordinate will be 0, 2. And B coordinate will be 0, negative 2. I'm going to do the same. So I have the same equation here. Y squared plus x equals to 4. And we know at C, which is on x-axis, so we're going to insert y at 0 this time. So I put 0 here. So x will be equals to 4, which is the coordinate for C value. So I'm going to write C as 4, 0. So we're going to take a look at two methods here, because for that equation, you can either arrange y as subject or x as subject. So let me arrange the subject over here for you. First, let me arrange x as subject. I will be writing 4 minus y squared. And if I arrange y as subject, so what you're going to notice is that I'll have 4 minus x. And if I take a square root, I'll have two answers. One is a positive and one is a negative. So let me write nicer here. Positive, negative. So I'm going to show you a method 1, which you usually see, and I'm also going to show you a method number 2. If you're interested to know, then you watch this as well. So let's look at method number 1. For method number 1, we're going to find the same area for these two methods, which is the area of OB and C, and later we're going to take away the triangle. Okay, so let's look at method number 1. What I'm going to do is to integrate this expression here in y. So if this expression is in y, here is going to write dy. And what happened to the limits that you're going to put here will be the coordinates that's on the y-axis. Okay, here's y, y. So you're going to look at the y-axis. So let's just take a look at the picture over there. If you look at the region, we are going to integrate here to here. So for this point, if you read over the y-axis, this position is 0. And for this point here, y will be equals to negative 2, which is our b value over here. Okay? And another thing to notice that this region over here, I'm going to write here, this is your y-axis. This is the region that's on the right-hand side of the y-axis. So when you do integration here, I'm going to place the value here first, where I have negative 2 and 0 here, looking at my y-axis. So this value here will be giving me a positive answer because of the position of the area is on the right-hand side of y-axis. So let's integrate this one. What you'll get is 4 integration will give you 4y, and this one here, raised power, divide by power. Let's insert the negative 2 and 0 in, and substitute 0 and negative 2. So you're going to do a minus here, substitution of negative 2. Answer, let me just read my calculator answer now. You'll be getting a positive 16 over 3. Okay, so let me erase that part here to show you method number 2. Let's take a look at method number 2. Now, we are going to integrate this one here. We have two signs, which is plus and minus. What's the meaning of this one here is that if you look at the y value of this curve here, this curve here is above the x-axis, so the y value is positive. So this one here is taking the positive version of 4 minus x. And this graph here is taking the negative version of square root 4 minus x. So we are still going to find the blue color region over there, which I'm going to make use of the negative version. So let me just write this one here. So now I'm going to integrate a negative version. I'm going to change the square root to power half. So what you see that this is in terms of x. So I'll write dx here. And what you're going to insert for this limit here, you're going to look at the x-axis. Where are you going to integrate? So for this one here, you are going to integrate from the starting x value is 0 up to the point C where x value is 4. Okay, now also notice that the x-axis is here and the area, what happened here is that it is below the x-axis. So what would you expect to get after integration is that you will get a negative sign because that gives you where the area is. So let's put this one here in 0 and 4. 0 here, 4 here. Let's do an integration now. We are going to raise power, so I keep this negative sign. Raise power by 1, I'll get 3 over 2. Remember to divide two things, the power and also coefficient of x, which is -1 in this case. Now let me adjust this expression a bit. This is negative, so I'll get positive. And I'll take 1 over 3 over 2. That'll give me 2 over 3. Once I write it nicely, let me replace 4 and 0 in. First, I replace 4. Second, I'm going to replace 0. So what happened here is that you will notice I will get the same value, but it's in the negative form. That's because the area is below x-axis. Okay? Now, let us now take a look at the area of the triangle because the answer over here is giving you the area for OBC, but not the shaded region yet. Let's find the triangle area. So the triangle is going to be half times base, which is the length of OC. That's going to be 4. And the height of the triangle is the length OB. So it's going to be a 2. So let's multiply this one. We'll have 4. So shaded area. Now remember that we are interested in the value of the area. So I'm going to take 16 over 3. So ignoring negative, this one gives the indication the area is below just now. So I'm still going to take 16 over 3. Take away 4. From here, you'll get the area of the shaded region as 4 over 3. So it's interesting to have a look at method number 1, which is normally what we will do because it's shorter. Okay? And there's a new perspective for method number 2 for area.